Hello, welcome to my channel. In this tutorial, we're going to talk about vectors and matrices. So without wasting my time, let's get to it. So I'll start up my MATLAB and then I'll create a new script. So you ask, what is a vector? So a vector is just a series of numbers or letters or strings. So please, if you have not taken a look at my other course, take a look at it. I start with strings and then variables, and then from there we talk a little bit about vectors, but we didn't really go through it. So today we are going to talk extensively on vectors and then matrices in MATLAB. Let's see how we can define a vector. So let me save my file first. I'm going to save it to vectors desktop. A vector is just a series of numbers, and in MATLAB we use the square brackets to define a vector. Okay, so when defining a vector, let me just get to it. So we use a square bracket and we write the numbers, and you can separate them by a comma or by a space. So we could equally do this same thing. So this is the same as what is there. We can separate them using a comma, or we can do the same thing using the space. Okay, so this is how to define a vector. Now let's see how we can quickly use the vector in our program. So we are going to define a vector and then store it inside a variable. And we are going to print out the vector using a loop. So I've also talked about loops in my other video, so take a look at it if you have not. Alright, so I'm going to name my variable as x, and I'm going to say equal to, and I'm going to define it as a vector 1, 2, 3, 4, 5. Alright, so now I have my vector. How do I print it out? So we are going to use the for loop to print everything out. So we are going to say for I is equal to 1 to the length of x, which is our vector. What do we want to do? We just want to display the index of the vector. So I can say display, and I'll call my vector and say 1, and I'm going to end the for. Okay, so what are we doing here? Now you can see here we have x, and then inside it we have a number. Okay, so the moment we do this in MATLAB, we are just referring to the index of the vector. So index 1 is 1, index 2 is 2, index 3 is 3, index 4 is 4, and this index 5. So it means when we change here to index 1, we are going to get 1. When we change it to index 2, when we change it to 2 here, we are also going to get 2. But we want to print all the indexes, so we are going to use a loop for that. So here we replace the 1 by I. When I is equal to 1, it's going to print out the index 1. It will go over, and when I is equal to 2, it's going to print the index 2. When I is equal to 3, it's also going to print the index 3, and to continue until the last index of the x. So let's run our program and see how it works. Okay, so when you save your file outside MATLAB, you just have to click add to path to run it. Okay, so let's see the result. We have 1, 2, 3, 4, and 5, of which are the same elements inside our vector. So this is how we can access the individual elements inside a vector. So if we want to call the fifth element, what we do is we mention the name of the vector, and then we use parentheses, and then we call maybe index 2. So we all know that our index 2 is 2. So we can equally call index 5, so x, and then index 5. So we can also print this one out, and you can see we have 2 and then 5. So it is from the index 2 and this index 5. So that's how you can actually access a vector. What I have not told you is everything inside MATLAB is stored as a matrix. Whether you save a number as 1, 2, 3. So for example, if I say y is equal to 1, this here is seen to MATLAB as a matrix. How do we check this or verify this? So let me create a new file, I'm just going to call it test. I'm going to save it on the desktop. Okay, so let me say y is equal to 5. So we all know this is just a simple assignment to a variable, and then we can check the size of y. Okay, so let's print out and see what happens. So you can see the size of 1 is a 1 by 1. So in MATLAB, it is regarding this particular variable as a matrix. It stores everything as a matrix. Without wasting my time, we have defined one vector, but this vector is a row vector. We can equally have what? A column vector. So y, and then we will define it as a column vector. So this is how to define a column vector. 1, and then we'll bring a semicolon, 2, semicolon, 3, semicolon, 4, and semicolon. We can add 5 to it. Okay, so the moment we use the semicolons inside the square bracket, we are saying that, hey, MATLAB, restrict this particular vector to a column vector. So let's print it out and see what we get. So you can see you're having the same thing. So we have the first one as x. You can just display x. You can also display y. Okay, so let me clear here first and run this code. So you can see this is what a row vector and this is what a column vector. So we can equally define both of them. You can define a row vector and a column vector. Okay, so in MATLAB, it's very easy to convert a row vector into a column vector. We just use a transpose. Okay, so this is how to do it. Call it here. Z is equal to X transpose. So this is how you see the transpose. So use the apostrophe as the transpose. So this Z is equal to X transpose. So when you transpose this particular vector, you know we are going to get a column vector. So let's print out and see what we get. So we can also display Z. Alright, so let's run this. And you can see we get the same thing as the column vector right here. So these are just the basics of vectors. We can also multiply a row vector and a column vector, which gives us a constant. So for example, I can multiply x and z, which will give us a constant because we have already transposed it. We can do that. So let's try that, and we can say x times z, and that should give us a constant, right? So that's 55. So that's the inner product space for the two vectors. Okay, so I've talked to you about how to access the individual elements and how to use a for loop to get all the elements inside a vector. So let's quickly take a look at matrices. So I'm going to create a new file for this. I'm going to save it as matrices. I'm going to save it on the desktop too. So what's a matrix? So a matrix is just a multi-dimensional vector or a multi-dimensional array. Okay, so let's look at how we can define a matrix in MATLAB. So we define a matrix by saying, let's assign it to a variable x is equal to, and then we can define it using the square bracket 2. So first I'm going to define a 2 by 2 matrix and then a 3 by 3 matrix. So I can say 1. We can also use the space 2 and 3, and then I'm also going to, so I'm defining a 3 by 3 first. 2, 2, 3, and 6. 2, 3, and 4. Okay, so this is my 3 by 3 matrix. I can also define y, which will be equal to 2, 3, 5, 5, 1, and 2. Okay, so what is happening here? The moment we terminate everything inside here with a semicolon, we create a matrix. So this is what a 3 by 3, so 3 rows and 3 columns. We don't actually need to do it this way for MATLAB to recognize it as a matrix. You can equally do everything in a line, and MATLAB will still recognize it as what? A matrix. So this is what I'm saying. we can leave it this way, and that one will also recognize as a matrix. But for simplicity's sake, I like to leave them this way. Okay. Okay. So this is a 3 by 3 matrix and a 2 by 2 matrix. So this is how to define a matrix. So let's see how we can access the individual elements inside a matrix. So before I talk to you, I said a matrix is just a series of vectors. We can equally get the index of a whole matrix, or the whole row of a matrix, or the whole row or the whole column of a matrix. So before that, we'll look at how we can get the individual elements from a matrix. So since a matrix is a two-dimensional array, we'll have to use both the rows and a column to be able to get access to it. So let me just show it instead of talking. Okay, so if I want to access this particular element here, which is 1, how do I access this from a matrix? So you can see from the vector, we just had to use the name of the vector, maybe y, or let's use x, and then we ring the bracket or the parentheses, and we put in the index that we want, because a vector is just a one-dimensional space or a one-dimensional array, but a matrix is a two-dimensional array. So let's see how we can do that. So to access this one here, we can see that 1 is on the row 1 and the column of what? 1. So if you are very familiar with matrices, the naming A11, A12, A13, yes, so use that to denote the indexes. Okay, so to be able to get the 1 in the x, we use x, and we use 1, 1. So this should actually bring us this 1 from here when we run the code. Okay, so let's run it and see what we get. So you can see we have the 1 here. The same way we can also get the 4 here, which is row 3, column 3. So we can say x 3 3, x and then 3 3. All right. Okay, so you can see we have the 4. So what if we don't want the individual elements, but we want the whole row or maybe the whole column? What we do is say the name of the variable, which is x, or the matrix, and now we do 1, which refers to the first row, but for the columns we use comma and we use colon. So the moment you use colon is in place of the column, or where you are supposed to put the column number, it will go and then bring you or fetch you the whole columns pertaining to row 1. So this is how it is. So let's run it and see what we get. So as you can see, we have the 1, 2, 3, which is right from here. Okay, we can also access the whole column, which is x, and maybe you have guessed it, is colon, comma, and then the column we want. So maybe we can let's take the second column, so we can put here 2. So guess what this one will do? Okay, so this also came to the second column and then brought us everything in the column. Okay, so this is how to get the whole column and then the whole row. Okay, so this is 2 3 3, and that's what we're having here. So this is how to access the individual elements or some parts of it. So what can we do? We can equally store these ones into different variables and even multiply them if you want to. A is equal to, and then B is also equal to. So with these ones we can multiply them and then use them any way that we like. Okay, so we can say A star B, and then let's see the answer we get. You should get a single number or a constant because it has been transposed. We are finding the inner product space for the two vectors. Okay, so this is how to actually deal with matrices and then vectors. But before we go, let's quickly take a look at how we can loop through a multi-dimensional array like the matrix and then print out its elements. So this could be a little tricky at first, but we'll get through it. we had to use only one loop for the vector because since it's only one dimension, but for the matrix it's a two-dimensional vector, so we have to use two loops. Let's see how we can do this. I'll just write the for loop and after that I'll explain how it is going to work using a matrix. So we're going to say for I is equal to 1, since we want to start looping from the index of 1 to the length of what the matrix we are looking for, so which is x. Okay, so let me just end this for loop here. Now if you realize, you can see if you want to access the individual elements inside a matrix, we use the row and the column. Okay, so in this first case, if we want 1, we are going to use row 1 column 1. So because of that, we have to use a nested for loop. Okay, so we have to declare another for loop. So we say for j is equal to 1 to the length of x again. What do we want to do here? Let me just end here. Okay, so what you are going to do, let me just write and after that I'll explain. We'll say display x, then taking in I comma j. Okay, so this is what we are doing. Let me just comment this one out. What we are doing is we first loop through all the elements inside all the rows in the matrix, and when we loop through the rows in the matrix, we need another loop to also loop through the columns of the matrix. So that's why we have two loops in question. We have the first for loop looping through the rows, and then second one looping through what? The columns. Okay, so let's take a look at this. We first start by looping around when I is equal to 1, which means it's going to take the first row, and then now when it gets the first row, now it will come into this one too, and then it will get the column. So what will the column? The column will be 1, since j will be equal to 1 on the first start. So what it's going to do is it's going to come here, and now it says, okay, so I should display x passing in I and then j. So what will happen? It will go and then fetch us what? The value at the column 1 index 1, and now it will increment this one to 2. One is going to keep on looping, so it will increase it to 2. Now it will become I 1 2, which also brings us the second element in the first row. It will increase this one again and then make it 1 3. So j will be equal to 3 since we are looping up to the length of what? X. So that will leave us to 1 3, and then that will give us all the elements in the first row. So when that one is done, it's going to come over to this and again increment it to 2, which will in turn fetch us our what? Second row. So that's how it's going to work, and then print out all the elements. Let's test this code and see if it really works. Okay, so I'm going to clear here, then I'll run the code. Okay, so now you can see we have all our elements, 1 2 3, and then everything follows. So this is how to loop through and then access all the elements in a matrix. We can multiply a matrix. We can multiply a matrix and a vector, which will give us a vector. So let's quickly take a look at that one, and we'll bring the tutorial to an end. Okay, so I'm going to save it to operation on matrix. Okay, so I'll save it to desktop. So I'm just going to copy these two matrices, the 2 by 2 and the 3 by 3. You know, before we can multiply any matrix, their dimensions must agree. That's the column of the first one must be equal to the row of the second one. So we can multiply a 3 by 3 matrix by a 3 by 1 since they will agree. So I'm just going to duplicate this one. I'm going to multiply it by itself. So to be able to just multiply two matrices, all we use is this asterisk symbol. So you can say z is equal to x star x. So this is multiply x by itself. We know how to get a subset from a matrix. We are going to multiply a matrix by a vector. So I'm going to take x. Okay, let me say v is equal to x times, and I'm going to get a vector from x itself. So I'm just getting the first column from x, so x, and then I'm going to use colon comma 1. So that will bring us everything inside the first column. So let's run these two. Let's display the answers and see what we get. So display y and display v, or not y, z instead. Okay, so let's see what we get. So we can see here, well, this when we multiplied x by itself, but when you multiply a vector and a matrix, it results in a vector. So you can see this is a column vector. So this will be the end of this tutorial. Hope you enjoyed it. See you some other time. Please like and subscribe to my channel if you enjoyed it. Thank you for watching.